All right, so once again, our objective for today, I can simplify exponential expressions with fractional exponents. I can simplify exponential expressions with fractional exponents. Tell your neighbor what concept we're still on, please. Concept. Very good, that was the objective. The concept for today was exponential expressions. All right, we know what they are. I gave you the definition. We know that we're looking at expressions only, not equations. They need to have exponents greater than 1. Steps. We wrote if the exponential expression has a fractional exponent, they rewrite as a radical and factor the number completely. Yes? So then I gave you some symbols. I said from now on, when you hear the word radical, you're going to see something like this. Is that correct? Yes. And then underneath here, the same thing. I gave you guys an example like so, and I said the index, which I circled in green, and I gave you guys the index outside of the radical was what, 4? So from now on, whenever you see a radical, the number outside is called a what? Index. And then step 3 says raise to the power outside of the parentheses, and at the end simplify. So just to reiterate on the steps, it says if the exponential expression has a fractional exponent, okay, so they're saying if it looks like that with a fractional exponent, what do we do? Number 1, we're going to rewrite it as a radical. So that means rewriting it using one of these. Yes? What is the other thing? We need to factor the number completely. And yesterday we started doing something like that, right? From there, identify the index, which means you're going to circle the index on the radical to find the root. From there, we're going to raise to the power outside of the paren, and at the end, we're going to simplify. Okay? So we got those. Next, I covered prime and composite numbers, and we said prime numbers, the first 5 prime were 2, 3, 5, 7, and 11. Is that correct? And we said prime numbers are numbers that can be factored only into 2 factors, number 1 and itself. From there, composite numbers, I gave you guys examples, not 2, I'm sorry. 4, 6, 8, and all of a sudden some of you start thinking, oh, all the evens. No, because from there I gave you 9, 10, 12. So therefore it's not all the evens. So what's the difference between these and the prime? That the composite have other factors aside from 1 and itself. So what does that mean? Let's see. Prime numbers. Factors of 2 are 1 times 2. Is that correct? Factors of 3, 1 times 3. Of 5, 1 times 5. Of 7, 1 times 7. And of 11, 1 times 11. Okay, let's look at 4. 1 times 4. Is that correct? What other 2 factors give me 4? 2 times 2. Notice that the definition says other factors aside from 1 in itself. So here's 1 in itself, but it also has some other factors. Look at 9. 1 times 9 or 3 times 3. Look at 12. 1 times 12, 2 times 6, 3 times 4. So other factors aside from what? 1 in itself. Everybody clear on that? Okay. And then from there we went into why do we need those? Because we need to know our first 5 prime. I said every time we start prime factorization of a number, you need to write your first 5 prime, which is 2, 3, 5, 7, and 11. And I gave you the number to find the prime factorization, which was what? 36. And then I asked you, which one of these prime divides 36? And you said 2. Somebody said 3. We're going to go with the biggest one, which is what? 3. So then we start a factor tree. 3 divides into 36. That becomes 12. I circle the 3. 12, what number divides 12? The 2 or the... So I'm going to go with a 3 because it's the largest one. So that's 3 times 4, and I circle the 3. 4 is 2 times 2. From there I said, therefore, we can rewrite 36 in factor form. That's what it's called. 3 times 3 times 2 times 2. Everybody with me? Yes. Yes, the question was, would have gotten the same thing if I started with like this? 6 times 6. Yes. The only thing, guys, the reason I asked you to start with a prime number, because some of you are going to make mistakes doing it this way. Check this out. And this has happened to you in the past. When you were back then in 7th grade, you did GCF, LCM to tell you how to do the factorization, right? Some of you started doing this, and all of a sudden you went like this, it was 2 times 3. And then all of a sudden, you just wrote 6 times 2 times 3. Is 6 a prime number?
No.
No. That's why you started making mistakes, because you did start like that, which is fine, but I need you guys, if you do that, you need to break this down also. So, to me, it makes a little bit more easier sense if you start with a prime and just work your way out and completely finish. Okay? Huh? Okay, 23. Damn. All right. So with that said, check this out. Write this down, please. From now on, whenever you see this, everybody look up to the screen. X to the 1/2. Write that down, please. Where we are taking notes. If it doesn't fit, turn it over. X to the 1/2. From now on, what is the first step? We said rewrite the fractional exponent as a radical. So check this out. We're going to write it like this. So if that, so check this out. X to the 1/3 is written like this. The third root of X. Write it down. Therefore, whenever you see X to the 1/4, therefore that is the fourth root of X. Now some of you already started seeing the pattern. How about if I have X to the 1/5? How would we write that? The fifth root of X. Hold on. Yes? Question? Right, we'll get to that. So for right now, I'm giving you just the main rule. Yes? So therefore, what would be this? X to the 1/32. 32nd root of what? X. Everybody understand how that works? Okay? All right, let's try it with numbers. Here we go. Copy this down. 9 to the 1/2. How would you rewrite that? Don't say it out loud, just write it. Okay? Who wrote this? Square root of 9. Okay? So now check this out. If I was to find the prime factors of 9, what are my prime factors? 3 times 3, is that correct? So therefore, this could be rewritten like this. Square root of 3 times 3. So now, do you guys notice, everybody look up to the screen, notice that here, X to the 1/3, we wrote a 3 as the index. Everybody see that? For this one, we wrote a 4 as the index. For this one, a 5 as the index. For this one, a 32 as the index. Which is the only one we don't write an index for? The half, right? Because we already know that this is a square root. Okay? However, if I was to write it, then what would we have right here? A 2. Is that correct? A 2. So let's look at our steps. Step 1, rewrite the fractional exponent, exponential expression with a fractional exponent as a radical. Did we do that right here? Step 2, identify the index. I'm going to circle the index, which is 2. Step 3, identify the roots. So let's see. This is saying this index tells us which number repeats how many times? Twice to give us this number, this product. So what number repeated twice? That's why at the end we get 3. Okay, let's do another one. 27 to the 1/3. Okay, let's do that one together. How about 3rd root of 27? Hands if you got that. Okay. From there, we need to factor the number completely. What number can divide 27? Prime factor. Remember, we start with a prime. 3. This is 3 times 9. You circle the 3, and the 9 becomes what? 3 times 3. So to rewrite this becomes what? 3rd root of 3 times 3 times 3. So then you circle your index, and it tells you which number repeats 3 times. The 3. That's what we get at the end. 3. Do another one. Here we go. Write this down. 16 to the 1/4. See if you can do that one by yourself. 4th root of 16. And then we broke down into prime factors of 16. It's divided by 2. That's 8. Divided by 2. That's 4. Divided by 2. That's 2. So we got 1, 2, 3, 4. This could be rewritten as the 4th root of 2 times 2 times 2 times 2. So therefore, we circle the index, and it tells us which number repeats how many times? 4. Which number repeats 4 times? The 2. That's why at the end we get 2 as the 4th root of 16. Yes. This one? This one? Yes. And the last one. Copy this, please. 125 to the 1/3 power. You can do that one by yourself. All right, for this one, you rewrite it. You got cube root of 125. Okay, we rewrite that. That became cube root of 5 times 5 times 5. Is that correct? So who got the cube root of 125 being 5? Okay, now we got it, right? Okay, so let's do some practice problems, see if you can do these. The only thing, some of them are going to have some addition, but the basic step, which is this, you already know how to do. So here we go. Copy those. See if you can do those by yourself. Example 1, it's a simplified expression. A, 343 to the 1/3 power. B, it's 32 to the 1/5 plus 9 to the 1/2. Okay, here we go. Just a hint. What did I say? Whenever we do any factor trees, we start with the first 5 primes. 2, 3, 5, 7, or 11. One of those usually has to give us one of the roots. And why? Because remember back in 6th and 7th grade when you guys worked on your divisibility rules? A number is divisible by 2 if it ends in an even number. A number is divisible by 3 if you add all the digits and if the number is a multiple of 3. A number is divisible by 5 if it ends in 0 or 5. No? Therefore, if none of those are it, then you go to the next one and see if that divides into that number. All right, here we go. Letter A. Who wrote it as a 3rd root of 343? Yeah, right? Okay, we at least got that down, right? From here, like I said, if it's divisible by 2, it needs to end in an even number. Is this an even number? No, so it's not 2. If it's divisible by 3, if I add all the digits, the number is a multiple of 3. Let's see, 3 plus 3, that's 6, plus